text, you are going to read about human impacts on Earth's water. Remember, when you first start reading a scientific article or text, you should first scroll through the article and look at highlighted vocabulary words. In this case, we have the word monitor, which also means measure and keep track of. Mitigate, that means lessen the impact of. We have a picture with a caption. The caption says, "This hydrologist heats up a water testing device that identifies toxic contaminants in the water." So we're going to learn more about the work of hydrologists. And then if you scroll further, you see that we have another picture that shows what appears to be a dam. The caption says, "Changes in the surface of Earth, such as this artificial lake formed behind a dam, can change storage and pathways of water in the water cycle." And then we scroll further, we have a picture with the caption saying, "Scientists have shown how much this Canadian glacier has receded by marking its position over time." And then if we continue scrolling, we see pictures of cows, and the caption says, "A dairy farm in Pennsylvania, TOP, uses a sustainable practice of processing cow manure into liquid fertilizers and methane gas that fuels electrical power. The construction site, bottom, shows a newly cut building pad that caused soil erosion in gullies next to the site." So we're going to learn more about how humans impact the environment and the Earth's surface. We also have an interesting looking chart that lists some common contaminants in water. We have aluminum. We see that it causes kidney damage. You can get it from rock and soil runoff. Glyphosate, also known as weed killer, that can cause kidney problems, reproductive difficulties. That is coming from runoff from herbicide use. Lindane, that can cause liver or kidney problems. That comes from runoff or leaching from insecticide used on cattle, lumber, gardens. Mercury, that can cause kidney damage. That comes from erosion of natural deposits, discharge from refineries and factories, runoff from landfills and croplands. Nitrate, we've heard about this. The potential health effects of nitrate. Infants can have symptoms including shortness of breath, blue baby syndrome, and death. Major cause of algal blooms, which can lower dissolved oxygen and cause dead zones. So overall, too much nitrate is really bad. Sources of nitrate are runoff from fertilizer use. Remember, nitrate comes from fertilizer. Leaking from septic tanks, sewage, erosion of natural deposits. Nitrate comes often from sewage and fertilizer. Turbidity, this is a new word. Potential health effects of turbidity associated with higher levels of disease-causing microorganisms such as viruses, parasites, and bacteria that can cause symptoms such as nausea, cramps, and diarrhea. That comes from soil runoff. Turbidity is how clear the water is. Water with high turbidity is not clear at all. Water with low turbidity is almost completely clear. Very, very low turbidity means that the water is clear. Also, we have the contaminant of solvents, such as trichloroethylene, vinyl chloride, and xylenes. We're going to be learning more about chemical pollutants. Those can cause liver problems, nervous system damage, and increased risk of cancer. They come from discharge from chemical factories, metal cleaning sites, petroleum manufacturing, leaching from PVC pipes. So we're going to learn more about different contaminants that can be in the water supply. And then here we'll be reading about mitigating human impacts on water. So we're going to learn more about water treatment plants. Here we have a picture of a municipal water treatment plant, treats millions of gallons of water each day. So remember, the wastewater would go through this plant and get cleaned enough to be discharged into a local lake or river. So now let's scroll up and we can start reading. The title of this text is Human Impacts on Earth's Water. Humans interact with water every day. Some interactions improve water quality while others have negative impacts. Unfortunately, the water people want to use is not always in the right place or of the right quality. And although the water cycle has been active since billions of years before humans even existed, human activities can affect how the water cycle redistributes Earth's water. Hydrologists are scientists that study how water moves around the Earth. They help us find new sources of water, monitor water quality, and determine best practices for water use and restoration. Hydrologists and engineers also work together to determine how to monitor or measure and keep track of contaminant levels in the water and mitigate or lessen the impact of contaminants. And take time to look at this picture. The water cycle. Water is one of Earth's most important natural resources. Humans rely on and use a lot of water in many ways. Our activities can also impact Earth's water in several ways. We can make water cleaner, we can pollute it, and we can affect its natural travels through the water cycle. Imagine water moving through the water cycle. Every second across the planet, water is changing its state and moving. Evaporation of water from the lakes and oceans adds water vapor to the air. When water evaporates from plant leaves, it is called transpiration. Condensation turns water vapor in the air into tiny solid and liquid particles that form clouds and fog. These droplets of water and ice can then fall back to Earth's surface as precipitation in the form of dew, rain, snow, or hail. Energy from the sun plays a major role in the water cycle. The sun's energy causes wind to blow and ocean currents to flow. Both of these processes move water around the globe. More heat from the sun causes more ice to melt and more water to evaporate. Less heat from the sun causes more water vapor to condense and more water to freeze. Solid ice melts into liquid water that flows into rivers and oceans. Gravity also plays a major role in the movement of matter in the water cycle by pulling water downwards. Contaminants, such as excess nutrients from runoff, can be picked up in nearly all parts of the water cycle. The process of evaporation is one exception because the liquid water changes to vapor, but typically the contaminants do not also change to gas. The water is evaporated into the air, but the contaminants are left behind. This process cleans the water that moves into the atmosphere, but also concentrates the remaining contaminates. The result is more potent contamination at that location. Human impact on the water cycle. People impact these earth processes because human activities use a lot of water. Sometimes when we use water, we alter the local balance of the water cycle. For instance, when we dam a river, it forms a lake and reduces water flow in the river downstream. In the lake, water evaporates more rapidly, and in the smaller river, less water is available. When we remove lots of water from lakes or rivers, the areas around the lakes and rivers have less water available and are more likely to experience drought. This can have devastating consequences for the organisms that live there. We also extract groundwater stored deep below the surface to use for a variety of purposes. Once on the surface, that water can evaporate more easily. As you have probably read or heard about on the news, measurements from across the globe indicate that the average temperature of Earth's surface is increasing. Evidence also indicates that various greenhouse gases added to the atmosphere by human activities, in particular carbon dioxide, CO2, are a cause of this global warming trend. This rise in average temperature has already affected the natural balance of the water cycle. Increased melting of glaciers and ice sheets has increased the amount of water and decreased the amount of ice. Human activities that affect the amount of evaporation or condensation that occurs can also affect the amount of clouds that form. Clouds both cool and warm Earth. Clouds can reflect the sun's rays back into space, causing surface temperatures to be cooler. Clouds can also act as a blanket, keeping surface temperatures warmer. While we don't know exactly what changes will occur, evidence makes it clear that human activities are causing changes. These changes are considered a major factor in the increase in severe weather events, such as storms, hurricanes, floods, droughts, and wildfires. In other words, our activities are changing the climate. Human impact on water quality. Human activities release contaminants such as nitrogen, salts, pesticides, metals, harmful organisms, and even medicines into the water. Even everyday activities such as cleaning can add washed off dirt, oil, sewage, and cooking scraps, as well as chemicals found in soap, detergent, and other cleaning products. When the human population was lower and there were no densely populated areas, natural processes and filters were able to remove the contaminants that we added. Ever since large numbers of humans started living close together in towns and cities, the amount of contaminated water produced in these areas began to overwhelm the area's natural abilities to remove contaminants. Initially, the contaminants were mostly from human and animal waste, but as human society began to include large-scale agricultural and industrial processes, many more and different contaminants began to enter the water supply. These contaminants can make the local environment unfit for life and can cause populations of some species to decline and possibly even go extinct. Personal water use is not society's biggest use of water. The two biggest uses of water are for agriculture and industry. Common agricultural water pollutants are nitrates, phosphates, disease-causing organisms, and sediments. Common industrial water pollutants are various toxic metals from mining, acids from chemistry and manufacturing, petroleum products, those come from working with oil and gas, asbestos, that comes from working with textiles, and cleaning solvents, that comes from working with electronics. Another large human impact on our water supply is land use, the clearing, leveling, digging, draining, and otherwise changing of the landscape that occurs whenever we build something. These activities tend to both decrease the solidity of soil and rock and increase precipitation runoff. These combine to produce more erosion and sediment pollution. The loss of the natural environment, particularly wetlands, reduces Earth's natural abilities to reduce pollution and maintain a balance. And even if what is being built is replanted, such as a farm field, park, playground, or sports field, the use and upkeep of these areas often require additional water use and add contaminants to water. To continue to have clean, good quality water for our own use and for use by the other organisms living on our planet, humans have had to take action. We have come up with new methods for obtaining naturally clean water and for cleaning the water we have contaminated. We have dug, then later drilled, wells to obtain water stored beneath the surface, built dams and aqueducts to trap and transport water from rivers and lakes, and engineered processes and machines to trap and remove contaminants before they get into the environment. Humans have successfully engineered solutions to control water, but it has not kept pace with the impact of land use. Monitoring Earth's water. Even though water continually cycles between land, ocean, and atmosphere, monitoring water quality is a fairly straightforward process. This is accomplished by collecting samples at key locations over time. The U.S. government, as well as many state governments, set limits for allowable levels of contaminants. Some of these contaminants are shown in the table below. Monitoring effects on the water cycle is not as straightforward as measuring water quality. This is in large part due to the long time frame required. The water cycle is a complex process. Natural fluctuations in water levels, sizes of glaciers and ice sheets, global temperature, and other phenomena need to be monitored. Because of this, it often takes many years to notice any changes in overall trends, such as global warming. Mitigating human impacts on water. Mitigation of human activities on water quality is even more challenging than monitoring. Once contaminants enter the water supply, it is difficult to remove them. They are constantly moving as they travel through the water cycle. The most effective method to improve water quality is to stop using all potentially harmful chemicals. This, however, is unrealistic. Many chemicals that can become contaminants are also useful. For example, nitrates help crops grow faster and produce more food. The next most effective method for reducing contamination is to limit the amount of contaminants that enter the water supply. This can be done by reducing the amount of chemicals used to the bare minimum needed. The wastewater and runoff should be thoroughly treated so contaminants are removed before the water goes back into the environment. Big spills can usually be discovered and cleaned up, but smaller everyday spills, such as a small oil leak from your car, often end up getting into the water supply. Another way to limit contamination is by choosing appropriate land areas for development and by designing buildings to minimize erosion and runoff. Mitigating human impact on the water cycle involves large-scale societal changes. Efforts to do this include reducing water use and limiting the amount of contaminants, including greenhouse gases, that are released into the water and air. This can best be done by making some sacrifices to reduce our consumption of resources and by investing in cleaner technologies that create less pollution.